8.6, confidence intervals. For confidence intervals, we'll use this formula here. The margin of error is equal to z star times the square root of p times q over n, where p is the sample proportion in favor, q is the sample proportion not in favor, and n is the sample size. Notice that p and q will always add up to 100%. Your confidence interval is equal to p plus or minus the margin of error. Okay, so the level of confidence, generally we speak about this one right here, a 95% confidence interval. So for example, if I were to flip a coin and it landed on heads, you wouldn't think, wow, that's an unfair coin. It landed on a head. You would just think, okay, that's a normal coin. It flipped on one side. If I flipped a coin again and it landed on a head, you might think, well, that's interesting, but probably you wouldn't think much of it at that point. If I flipped a coin again and I got a head and I got 3 heads in a row, you still probably wouldn't question me too much. However, somewhere in the 4 to 5 zone where I keep flipping a coin and getting a head, somewhere in that 4 to 5 zone, you start doubting whether I have a fair coin in my hand and whether I'm cheating you out on this. So in that 4 to 5 zone is called the 95% confidence. It's about a 95% chance that I could have all heads in a row, flipping a coin 5 times. And so somewhere in our human psyche, we start distrusting things in that 95% zone. If something is 90% chance of happening and therefore a 10% chance of it not happening, we don't tend to doubt it too much if it doesn't happen, because 10% is quite likely. We also don't need to get to the crazy 99.7% interval. These Z star numbers that we're going to use, they come from the Z chart, and that's referenced in another lesson. So let's take a look at this. Sample confidence level questions. According to an Ipsos poll, which is not a real organization but close to a real one, 29% of Canadian Pokemon Go players say the game is overtaking their lives. Do any of you remember when Pokemon was overtaking people's lives and people were chasing them around in parks and cities and possibly getting hit by cars as they were searching for their Pokemon characters? Well, okay, made up question on this. Okay, they polled 1,100 Canadians between July 20 and July 25 of 2016. Let's figure out a confidence interval for this survey. Okay, so 29% of Canadian Pokemon Go players said they have this, but just because in our sample there's 29% doesn't mean that the true population is 29%. So we can give a true population and a confidence in our sample size, okay? So we're going to use this formula here. The margin of error is equal to Z star times square root of P times Q over N. All right. So Z star, we want a figure out the confidence interval. So I've told you, let's pick 95% every time, unless it says something else, because 95% is where we lie. So Z star for 95% is 1.960 times the square root of P. Well, in this question, P is equal to 0.29. Because 29% of Canadian Pokemon Go players say the game is overtaking their lives. So we put in 0.29. Q is equal to 1 minus 0.29, which is 0.71. And we put that over N, which is our sample size, and here 1,100 Canadians were polled. When we take these numbers and we multiply them out, what we get is 0.027, which is equal to 2.7%. That means my margin of error is 2.7%. So how can we apply this to the question, and how would you publish this kind of information? So if you're just trying to get the average reader just to understand simple data, you just say 29%, say that. But to truly be honest with our data, we need to use wording like this. So I am. So how confident were we? Well, we used a 95% confidence interval. So I'm 95% confident that the true population and here it's the mean or the proportion, the true population mean of Pokemon Go players, or I should be more specific, Canadian Pokemon Go players who say the game is overtaking their lives. So that's the variable here, okay, is between. And so what is it between? So the lower bound on this question, so let's do the lower bound here. So the lower bound is P minus the margin of error. So here we had 29% in the sample size said that it's overtaking their lives, minus 2.7%, which is 26.3%. The upper bound is P plus the margin of error, and that is 29% plus 2.7%, which is 31.7%. So we are 95% confident that that variable is between 26.3% and 31.7%. So that means when I go to the true population of Canada, I would actually think that it's somewhere between 26 and 32%, 31.7% is the true population, because getting that answer once with one sample doesn't mean that that is the exact number for all of our population. It just reflects one sample. So we think it's about 26 to 31%, but we're only even 95% confident of that is true. But 95% confident is pretty confident. What would happen if I made my confidence level more exact? Well, if I said I wanted to be 100% confident that this was the true population, I'd actually need to make the range bigger, because I would need to allow for more possibilities. And if I want to be less confident, then I can be more exact in what I think people are saying. Let's go to another example. A newspaper stated that 70% of the population supported a particular candidate's position on healthcare. In a random survey of 50 people, 31 agreed with the candidate's position. Test the significance of this result with a confidence of 90%. So we're using a 90%, which according to our chart, 90% is 1.645. So 1.645 will be our Z star, okay? P is the proportion in who agreed with it, which was 31 over 50, or that's 0.62. Q are those not in favor, so that's everything that's not in P, which would be 0.38, 38%. Okay, we're going to test this out now. So the margin of error is equal to Z star times P times Q over N. So Z star is 1.645 times P, which is 0.62, times Q, which is 0.38, over N, and the sample size here was 50. When we multiply these out, we get 11.3%. Okay. So the newspaper stated that 70% of the population supported a particular candidate's position on health care. They the probability they got was 62%, which is it's lower. So it's lower than 70%. But the problem is that in this question we had a margin of error of 11.3. So that means this could actually truly be all the way up to 73.3% when we add 11.3. Or it could be lower than that if we subtract 11.3, right? So that gives us 50.7%. Okay, so really their findings are that somewhere between 50 and 73% of people support that candidate's position, which this is within that range. Okay, so have things changed? Well, we don't really know because this test didn't give us confidence that it lay outside of the range. So our conclusion would be do not print the correction. Since we are unsure if anything has changed. Okay. Next example. Does advertising influence behavior? For sure. But let's test it out with this question. Before a recent advertising campaign, a children's breakfast cereal held 8% of the market. After the campaign, so they carry out this campaign, they do a study, and 18 families out of a sample of 200 families indicated that they purchased the cereal. Was the advertising campaign a success? So obviously, here we have 8% before. Okay? After, they have 18 out of 200, which is 9%. So what happened? Well, it increased. So there's a 1% increase in those in favor of this cereal. Let's test this out. So this is what we're going to test out. So we see that there's a 9% probability. So our margin of error is equal to Z star times P times Q over N. And we need to pick a confidence interval that you're confident with or you're comfortable with. So again, anytime you're given an option, I say go with 95%, which is 1.960. So 1.960 times, where our P is 0.09, that's 9%. Our Q is 0.91, everyone who's not in favor of that cereal, over the sample size, which is 200. When we multiply that out, we get 0.04, or 4%, okay? Which means that we're looking at somewhere between, let's go for our low high. So for low would be 9 minus 4%, which would be 5%. So, and our high would be 9 plus 4%, which is 13%. So somewhere between 5% and 13% of families indicate they purchased a cereal. So is this an increase? Well, this is what our answer is. It's not actually 9%. It's somewhere between 5 and 13%. And 8% is, again, caught within that range of where we actually found the results to be. So this, let me change that. So 8% is within the sample size confidence interval. So we are not confident that the advertising was a success. Okay. So part of the questions that arise out of this, and you'll notice this in the last two questions, here we have a sample size of 200, here we have a sample size of 50, and you'll notice that the ranges were very, very large, and therefore it's not very useful. Whereas this one here, where we pull 1,100 people, the margin of error is only 2.7%. And that makes for data that's a little bit more clear, between 26 and 32% there. So, having a large sample size is very important. And I can compare this to the idea of if you're ever making soup or chili, when you add spices into it, you don't need to eat the whole pot to know whether it's got the right spices in it. If you stir it around, which is equal to the idea of having a random sample, so if you stir it up and take a spoonful, you can actually get a good sense as to whether your spice is right. Now, you can't be perfect in it, but you can be somewhat confident. So the question is, how big does your spoon need to be? Can you use a little teaspoon? Can you use a larger spoon? How large is that spoon? So with food, you can choose what size spoon you want to test your food with. But with sampling and population sampling, around 1,000 tends to be that number that you want to work with. So this is confidence intervals. You'll see this in papers all the time, especially around political poll times. I want you to be aware that when you hear that the conservatives have one number and the liberals have another percent of the value, and that's only separated by 1 or 2%, the reality is that isn't worthwhile of publishing that one is winning and one is losing, because the margin of error will likely include both of those sample sizes. And so therefore, really, it's kind of still a tie game, and no one can put their finger on who's going to win at that point. And that actually only reflects the results of that day. It doesn't tell us what's going to happen when people now vote, because people change their vote after they see results like this.